Hey guys, it's Tiffany from SuperEasyMath.com. Today we're going to talk about the quadratic formula. Solving using the quadratic formula. Video 2. Some things to keep in mind. When you're solving a quadratic equation, your goal is to calculate what x equals in that equation. You need to make sure that you start with an equation that is listed in standard form, which looks like this. ax squared plus bx plus c equals 0. The quadratic formula that you'll use to solve the equation looks like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's take a look at example number 1. Example number 1 is 4x squared minus 2x minus 30 equals 0. Before I begin, I'm going to make sure I have the quadratic formula written up above so I can refer to it at any time throughout this process. Next, I'm going to identify the different parts of the quadratic formula that I need to pull out of this equation. So a is going to come from this first term, b is going to come from my second term, and c is going to come from my third term. I'm going to clarify even more so what these values are over here to the left. A equals 4, b equals negative 2, and c equals negative 30. I want you to remember that whenever there's a subtraction sign in front of a term, you need to make sure you take that sign and count it as negative on that coefficient. So for our b value, it's not just a regular 2, it's a negative 2 because there's a subtraction sign right in front of it. The same thing is true for the c. This isn't a positive 30, it's a negative 30 because there's a subtraction sign in front of it. Now I'm going to plug these values into my quadratic formula. I'm going to start by rewriting the formula except plugging in the values into it as I get to each value. So I have x equals negative b, but when this scenario happens, so I have x equals, and now it's time for me to write negative b, but our b is already negative, so I'm actually going to realize that two negatives make a positive, so this will actually end up being a positive 2. What I mean is, if I were to start writing the quadratic formula and I have x equals negative 2, these two negatives would just cancel out, so it would end up being x equals positive 2. So I'm going to jump straight to this step, but up here where I'm rewriting. So I have x equals positive 2 plus or minus the square root of b. Now I do need to write negative 2, and this should be squared. I'm going to put this negative 2 in parentheses to clarify that I need to also use the negative sign when I use that exponent. Now I'm going to subtract 4a, which is 4, and c, which is negative 30. All of this is over 2a, or 2 times 4. Now I'm going to rewrite all of this, but simplify it as much as I can. So I have x equals 2 plus or minus the square root of, I have negative 2 times negative 2. Remember, an exponent tells you to multiply whatever the base is, or the larger number, that's kind of like the normal number, by itself that many times. So we have negative 2 times negative 2, and 2 times 2 is 4, and 2 negatives equal a positive. So this just ends up being a positive 4. Now I'm going to start by rewriting my subtraction sign, and now I'm going to multiply these numbers. I have 4 times negative 30, and that would give me negative 480. Well, again, just like we had the scenario over here of a negative and a minus together that ended up being a positive, we would have the same thing over here, a subtraction and then a negative. So that's going to just result in a positive. So instead of 4 minus our answer, it's actually just going to be 4 plus our answer. And our answer again is 480. Now I'm going to write all of that over 8. The 8 came from multiplying the 2 and the 4 together. Now I'm going to simplify even more. I have x equals 2 plus or minus the square root of 484 all over 8. X equals 2 plus or minus. If you do not know, you can guess and check a few times. I know that 20 times 20 is 400, so I know that the square root of 484 is going to be pretty close to 20. And if you had to guess and check a few more times, hopefully you'll get the correct answer, and it is 22. So 484 is a perfect square. The answer to it is 22. Now I'm going to put my denominator here, which is 8. Now I'm going to realize that this is telling me I have two separate problems. I can have 2 plus 22 all over 8, and I can also have 2 minus 22 all over 8. To clarify that I'm doing two separate problems now, I'm actually going to change colors to make sure it's clear. So right now I'm going to do the 2 plus 22 all over 8. Well, 2 plus 22 is 24, and then 24 over 8 equals 3. Now I'm going to do the same thing, but in the opposite version. So I'm going to use a different color for that. I'm going to do the 2 minus 22 all over 8 and get an answer for that. That gives me negative 20 over 8. And then that simplifies to negative 5 over 2. Now I know that the solutions to this equation are x equals 3 and x equals negative 5 over 2. Now I'm going to show you how you can check your answer to make sure it's correct. If you want to check your answers to make sure what you got is correct, you need to understand that we just calculated the value for x. So that means I can plug in both the 3 for x and the negative 5 over 2 for x, one at a time, and it would give you that this left side of this equation equals 0, okay? So I'm going to say that again. If I take this 3 and plug it in everywhere you see an x and solve everything on the left side, it's going to give me 0. Likewise, if I plug in the negative 5 over 2 in this equation on the left side, you're going to end up with a 0. If I were to plug in another number that's not one of our answers, I would not get 0. Let me show you what I mean. Let me show you what all of that looks like. 4, instead of writing x, I'm going to write 3 squared minus 2 times 3 minus 30 equals 0. So I've written the exact same equation, except every time it was time for me to write an x, I wrote a 3, and I put the 3 in parentheses to clarify that I'm multiplying. So now I'm going to work all of this out. I can work this part in my head, and I know that 3 times 3 is 9, and 9 times 4 is 36. So I'm going to replace this first term with 36. Now I'm going to subtract 6 from that, because that's what I get when I multiply 2 and 3 together. And then I'm just going to rewrite this minus 30 equals 0. Now, if I have 36 and I take away 6, I have 30. And then if I have 30 and I take away 30, I get 0. So that works. So this is 0 equals 0. So it checked out for our x equals 3. Now I'm going to show you that it's going to check out for our x equals negative 5 over 2. If I have 4 and I plug in negative 5 over 2 for our x and put that squared, and then I subtract 2, and again, instead of x, I'm going to write my negative 5 over 2. And then I'm going to subtract 30. I need to get 0 to prove that this is true. So this is a little bit more complicated of a problem. So I have negative 5 over 2 times negative 5 over 2, and that's going to give me 25 over 4. Now I'm going to rewrite that as 4 times 25 over 4. And then I'm going to subtract the next part. I can see that I have a whole number and I'm multiplying it by a fraction. I don't know if you remember this, but whenever you have that scenario, you take the whole number and turn it into a fraction by giving it a denominator of 1, and you still want to multiply it by the second fraction. So I have 2 times negative 5, which gives me negative 10, and that's over 2. And then that results in negative 5. So now I have, instead of minus 2 times negative 5 over 2, I have minus negative 5. But like I explained to you when we were originally solving the problem, two negatives next to each other make a positive, or you could even understand that a subtraction sign and a negative next to each other make a positive. So I can just change this to a plus 5, and the negative basically just drops. Then I'm going to subtract 30, and I'm going to get 0. Now I need to multiply this part. So again, if you remember, when you're multiplying by a whole number, you want to take your whole number and turn it into a fraction by giving it a denominator of 1. Then you're going to multiply it by the other fraction. So in this case, the other fraction was the 25 over 4. So now I have 4 times 25, and that's 100. And then I have 1 times 4, and that's 4. Well, 100 over 4 equals 25. So now this first term turns into 25. So now I have 25 plus 5 minus 30 equals 0. But let's see if that's true. If I have 25 and I add 5 to it, I get 30. And then if I have 30 and I take 30 away, I get 0. So 0 does equal 0. So that was correct. But now to prove to you that these are the only two answers that would work for this particular equation, I'm going to plug in a different number. I'm going to plug in a number that's not 3 and a number that's not negative 5 over 2 to show you that it's not going to result in your equation being balanced, meaning it's not going to result in 0 equaling 0 like these two answers resulted. So let's say I plug in the number 2 for x. I would have 4 times 2 squared minus 2 minus 30 equals 0. So 2 times 2 is 4. 4 times 4 is 16. Minus 2 times 2 is 4. Minus 30 equals 0. 16 minus 4 is 12. 12 minus 30 is not 0. So I can see that that does not give me the correct answer. So even though I've already said it, I'm going to say it again. The only two answers that x could be that will make this problem work out to be balanced, meaning everything on the left turns into 0, which is going to keep our equation equivalent since what's on the right is 0, are the answers x equals 3 and x equals negative 5 over 2. Now let's take a look at example number 2. Example number 2. Again, I want to start off by writing my quadratic formula up at the top. Then I want to clarify my a, b, and c values. A is 16, b is a positive 34, and c is a positive 15. I'm going to rewrite those over here to the side. A is 16, b is 34, and c is 15. Now I'm going to plug these values into the quadratic formula. I have x equals negative b, which is negative 34, plus or minus the square root of b squared, or 34 squared, minus 4a, which is 16, c, which is 15. All of that is over 2a, or in this case, 2 times 16. Now I'm going to rewrite all of this, but simplify everything I can. I still have my negative 34 plus or minus. Now I need to work out everything on the inside. I have 34 squared, which is the same thing as 1156, minus 4 times 16 times 15 gives you 960. Can't forget to write my square root. Then all of that is over 2 times 16, which equals 32. Now I'm going to rewrite this, but simplify the problem under the radical. So I have x equals negative 34 plus or minus the square root of 196 all over 32. Well, 196 is a perfect square. 14 times 14 equals it. So negative 34 plus or minus 14 is what we get right here. And then all of that is over 32. Now, Remember, this plus or minus tells us that we have two different directions to go now, which is going to result in two different answers. The first one is x equals negative 34 plus 14 over 32. When I go straight across from left to right with my numerator, I have negative 34 plus 14, and that gives me negative 20 over 32. I can simplify that by dividing 4 into my numerator and denominator, and I end up with negative 5 over 8. Okay, so now we're going to do the exact same thing, but we're going to take this second version of our sign. We had negative 34 plus 14 over 32. Now we're going to do our negative 34 minus 14. So x equals negative 34 minus 14 over 32. Now I'm going to subtract here. I have negative 34 minus 14, and that's going to give me negative 48, and that is over 32. Then I can simplify negative 48 over 32 because 8 can go into both, and I get negative 6 over 4, and then that can simplify again to negative 3 over 2. So my answer for this one is negative 1.5. Now I'm going to clarify my answers. The only two things that I can plug into this equation that is going to give me a true statement or a balanced equation is x equals negative 5 over 8 and x equals negative 1 over 1/2. So again, like I showed you in the first example, if I were to plug these two values into my equation, I'm going to get 0 on the left, and that would equal the 0 on the right. These are the only two numbers that would allow that to happen. There are no other numbers that you could plug in to get 0 equals 0. Now let's take a recap. When you are solving a quadratic equation, your goal is to calculate what x equals in that equation. You need to make sure that you start with an equation that's listed in standard form, which looks like this. ax squared plus bx plus c equals 0. The quadratic formula that you'll use to solve the equation looks like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you try. Comment with the correct answer below, then head over to my website and click on video answers to see if your answer is correct. 3x squared minus x minus 2 equals 0. Solve for x using the quadratic formula. SuperEasyMath.com. Don't forget to like and subscribe. Did you find this video helpful? You can support this channel by donating to Super Easy Math through PayPal. There's a link to it in the description section below this video and on the Super Easy Math YouTube cover photo.